Hello, Mr. Ryan, right? Okay, so give a list. Okay. Wow, you're quick.
Ta-da.
Okay,
That's
so
one way.
yeah, 3 to the power of 0 plus 3 times 3 equals 10. Or obviously you
1
can
plus 9
yeah.
equals 10.
Obviously you can swap, yeah? So you can 3 times 3 plus 3 to the power of 0, okay? And then okay. Yeah, that's another way. Any number to the power of 0 equals 1. A is not equal to 0, okay? So mathematics speaking, 0 to the power of 0 is not defined. And another way is to use the
square root.
Square root?
Flooring.
Flooring. Okay, so the other way is the
Square root. Well,
okay. So this is flooring, eh? This is ceiling. Derangement, we talked about that in roughly 100 days. Derangement. For example, you're given 3 letters and you want to put it in the mailbox numbers from 1 to 3. So there are 3 more ways. 3 mailbox.
You can't
1,
put
2,
it in
3.
your.
And then you have 3 letters, yeah? 3 letters.
Or could be anything.
1, 2, 3. So derangement is that the number of ways you can put this in the mailbox, but not in the box of itself. Okay. So 1 cannot put it into 1, 2 cannot put it into 2, 3 cannot put it into 3. So we have this 3, 1, 2. That's good, right? And also 2, 3, 1. All right. There's only 2 ways. You know, this symbol is factorial, right? N times n minus 1 times n minus 2 times q1. And if you put this exclamation mark in the front, this is derangement. Okay, so exclamation mark 3 equals 2. And how about exclamation mark 2 equals?
Exclamation mark 2 equals 1.
Equals what? And exclamation mark 1 equals what?
0.
We have n letters and n boxes. And how many ways? If we use this fn, meaning the number of ways to put these n items into n boxes, the 1 cannot be put into number of itself. If I'm considering here, the number here, this nth item, the number n, I can put it into n minus 1 ways, right? I cannot put it here, right? Obviously, yeah? But I have n minus 1 choice. N minus 1 choice. So if I put it here, k for example, then one way is I can swap this k with n, right? If I swap it, and the rest would be, the remaining would be n minus 2, right? Am I right? Because this item 1, this item 2. So n minus 2, then that would be f n minus 2, right? If I'm not swapping with the nth item, then I have n minus 1, f n minus 1, am I right? Yeah? So I plus f n minus 1. Okay, so this is the derangement recursion formula. Fn equals n minus 1 times fn minus 2 plus fn minus 1. Okay, we just talked about that. We can implement this using recursion and putting the cache, right? Like a Fibonacci number, that would be a dynamic programming, top-down dynamic programming. Okay, so coming back to this question, so 3, 3, 3, how can we make a 10? So it's, this is 2 plus 3, that's 5, times 2 equals 10. These are the 4 ways, okay? Define fn, we'll put a cache to remember the intermediate value. If n equal 1 or 0, right? If it equals 0 or equals 1, return the value will be 0. f0, f1 is 0. If n is 2, return 1, right? There's only one way. And then we can return fn minus 1 plus fn minus 2. This is Fibonacci number, but we need to times n minus 1. Okay, this is recursion with minimization, top-down dynamic programming. Okay, we put a cache, so the time complexity will be O(n) because the maximum number of states we're remembering, we're calculating is n. We can also use the bottom-up dynamic programming. Okay, so we use the array to store the values. So we calculate f0 and then f1, f2, and we can calculate f3, f4 until fn. This is like Fibonacci number. So define fn. Obviously this still applies. So we use the pp equals 0 times n plus 1. pp2 equals dp2 equals 1. For I in range 3 until n, then dpi equals I minus 1 times dpi minus 1 plus dpi minus 2 return dpn or dp minus 1. So quite similar to Fibonacci number, right? This is the difference. Yeah, this is the difference. Have you noticed that DPI, we want to calculate DPI only based on DPI minus 1 and minus 2. We can use the two variables to iteratively instead of use the DP array, right? Because this one, the space complexity will be O(n). We are using the array to store the values. So we can use two variables. So A, B equals 0, 1. Okay, so we don't need this. And then AB equals B, and then A plus B times I minus 1. Okay, and then return B. This implementation is the most efficient, right? Because we use the iterative, and then we use two variables to keep tracking the values. What have you learned today?
2.
So if you want to
time we done this 0, 0, 0 equals 10, 1, 1, 1 equals 10.
So okay, so what have you learned today, Sama? What's derangement?
About resorting it, but you can't put your letter or email or whatever you're doing into your own one. Derangement 3 equals 2. Derangement 2 equals 1. Derangement 1 equals 0.
Okay, so okay. Yeah, so basically derangement. We talk about this. Yeah, derangement. There are n items. We want to find out the number of ways to put these n items into these n boxes, n places. But each item cannot be put into the number of its own, and we want to find out the number of ways of doing that. So that's quite useful in real life. For example, like you and your friends, right, preparing the gift, birthday gift. You want to exchange birthday gift. How many ways can you do it, right? You cannot give yourself your own present, all right? Yeah, so that's the derangement. For example, like how many students in your class?
About 30.
30. Okay, so the derangement 30. So for example, like all of you prepare the gift. Estimation mark 30, right? This is a very big number, so we can use this formula. Fn equals n minus 1 times Fn minus 1 plus Fn minus 2. Okay? So this part is Fibonacci, we just need to times it with n minus 1. And the way to understand this, we have talked about that as well. This is that we considering that looking at the nth item, and then how many ways can we put this nth item? There are n minus 1 ways, right? Obviously, you can put it in the last item, you can put it in the first n minus 1 items. And suppose the 1, we can put it into the number called k. And then there's two situations. One way is that you can exchange, you can swap k and n. And then that leaves us the Fn minus 2, right? Because there are n items, and then k and n, there are 2 items. The remaining will be Fn minus 2. If we are not putting the k at the end, so there are Fn minus 1 ways to do that, right? So that comes with this. Okay, that's it for today. Bye-bye. Bye-bye.
Bye.